Okay, today we're going to do a little bit of review of an integration technique called integration by parts. And we're going to need to use this technique to solve this logarithm, and then we're going to need this this integral, and then we're going to need this integral to solve a little harder one, and then we're going to use that one to solve an either harder one. So it's just going to kind of step up here and get harder as we go. So let's review integration by parts, where I'm going to derive where it comes from. So we'll go back to differential calculus here, and if I'm taking the derivative of a product of two functions of x, so u and v are both functions of x. They're being multiplied together. You remember that it's the first times the derivative of the second, and we're just going to write that as dv, and the second times the derivative of the first. So this is the product rule. And to derive integration by parts, we're going to prove this by integrating it, anti-deriving both sides. So if we do that, of course, the fundamental theorem of calculus says if you take the antiderivative of a derivative, you get what you start with. So we're going to get that uv is equal to the integral of u dv plus the integral of v du. So what does this do? Well, now we can solve for one of these two. I want to solve for this one here. So if I just solve for this integral here, so if I take this and put it over on this side, and then subtract this from both sides, I'd have this is equal to this product minus the integral of v du. And this is the formula for integration by parts. And I'm going to write it down before I explain, because we're going to use it again. So we're going to have the integral of u dv is equal to uv minus the integral of v du. Now, so this is kind of like the product rule, but it's kind of different because we're multiplying two things together, but one is something that I can differentiate, and the other function is something that I can anti-differentiate. Okay, so we're going to start with an easy one here, this natural log of x. And I've got my formula down here, so we're going to start with this. Now, I know the derivative of ln x, and I know the antiderivative of dx. So it's something I have a derivative of and a function that I can differentiate, which most functions you can differentiate. So that's not the issue. So this here is going to be my u, and dx here is going to be my dv. So I'm going to use this formula below. Let's solve for these two here. If I have u to be natural log of x, that means du is dx divided by x. And dv is dx. This is the easiest one to anti-differentiate. That's just x. And I'm going to leave the constant off while we do this, because we're going to add a constant to the end of the whole thing anyway. So let's see. We have uv, which is u times v minus the antiderivative of v. V is x times du. Dx divided by x. Well, what is x times x? This is just dx. Okay? X times 1 over x, and then what's left in the denominator is dx. And this we can handle because this integral is just x. So the answer here is going to be x times the natural log of x minus x plus a constant. So we're going to use this when I do the next antiderivative here. So the integral of the natural log of x is x natural log of x minus x. And we'll put plus c down. Okay, so this is the main meat of it. And yes, you can factor an x out, but that doesn't really help us. Okay, we can factor an x. So, this was the easy problem. Let's go on to use this to apply to something a little harder. And not much harder. Instead of the natural log of x, we're going to find the natural log of x squared. The antiderivative of the natural log of x squared. So I'll have a u, and I'll have a du, a dv, and a v. And so we have two functions multiplied by each other, and they're the same one. So u is going to be the natural log of x. And now that I can anti-differentiate this, since I have it right here, dv is also the natural log of x. So we got a dx on there. Okay, so this one of these is the derivative, and one of these is the function we're going to derive. And again, du is dx over x. But v is going to be the antiderivative of this, which is x times the natural log of x minus x. Okay, so we're going to use this integration by parts formula. Be very careful with your signs. Very careful. It's really easy to lose track of your signs on here. So u times v, that one's easy because everything's pretty much positive, is x ln x minus x. And instead of natural log of x, sometimes I say ln x. That's perfectly normal. Okay, there we go. Now, here's the hard part. We're going to lose a sign. We're going to take away the integral of ln x minus 1 dx. Okay. This is what is often overlooked. Even I've done this. This is a plus. Because if you subtract this and you subtract a negative, this becomes a plus. So be very careful with these. Okay, so let's simplify this a little bit. When we multiply this across, we're going to have x times the natural log of x squared. Okay, so if I multiply this times this, minus x times the natural log of x. Now, minus the natural log of x, the integral of the natural log of x, which is x ln x minus x. But you're subtracting it, so it's minus x times the natural log of x minus a negative is plus x. Okay? Now, because if I did this all in parentheses like this, it would be minus x ln x minus times a minus is a plus. So this becomes a plus x. Okay, and we still haven't dealt with this 1 yet. Minus a minus is plus x again. So, when we do this antiderivative, we get x times the natural log squared of x, or x times the natural log of x squared, minus, well, here's 1x natural log of x, and here's another one, so that's 2x times the natural log of x, and then there's an x, plus 2x plus c. So this is going to be the integral of the natural log of x squared and let me box this. And this is a brief example of integration by parts. If you need and I appreciate your time. Thanks for watching.